Hey guys, welcome to Calculus Daily, episode 19. We're looking at achieved questions in all of these three standards. So off we go. All right guys, so with this question we have a quadratic where a equals to 1, b equals to minus 4, and c equals to 16. And because we're asked to find the solutions for x, we're going to use the quadratic formula for this particular question. Okay, so just fit this in. Substituting all my values, I've got negative b, which is negative times negative 4, plus or minus b squared is negative 4 squared, minus 4 times 1 times 16. The whole thing is divided by 2 times 1, which is 2. So I have 4 plus or minus square root of 16 minus 64 over 2. And this can be written as 4 plus or minus negative 48 over 2. Now, I know that I can write negative 48 as 48i squared, as I squared is equal to negative 1. And simplifying this, 4 plus or minus. Now 16 is a factor of 48, where 16 is a perfect square. So we've got 16 times 3 I squared over 2. And this could be simplified as 4 plus or minus 4i root 3 over 2. And this simplifies to 2 plus or minus 2i square root of 3. Cool, that's it for this question, guys. Okay, and yeah, that previous question we could have actually just left it as, we could have done further things to it, but 2 plus 2 root 3i is fine. On to this one here, we have given that this complex number w equals 2 cis pi over 3, find w to the power of 4. Now, so I'm going to do w to the power of 4. So I've got 2 cis pi over 3 to the power of 4, which means w to the power of 4 is going to equal 2 to the power of 4 cis pi over 3 times 4 as its argument. So 2 to the power of 4 is 16, and 16, is it right? 2, 2, 2, yep, 16, and then we have 4 pi over 3. So to convert this into a plus bi form, you could write this as 16 cos 4 pi over 3 plus 16 I sine 4 pi over 3. And when you calculate this, you will get your complex number in a plus bi form, which is minus 8 minus 13.86i. Cool. Next question. Got a couple of differentiation questions here, folks. The first one, we're looking at it, it's quotient rule. So I'm just going to put it on the side there. Oh, I hate it when they use f of x. Let's use u and v. All right, so u dash is going to equal 4e for x, and then v dash is equal to 2. So because this is a quotient rule, we can write f dash of x is u times, so it'll be u dash, which is 4e for x, multiplied by v, which is 2x minus 1, minus u, which is e to the power of 4x, multiplied by v dash, which is 2, and that whole thing is divided by v squared, which is 2x minus 1 whole squared. And that's the first part of this question. Well, not the first part, that is the actual question. That was actually an achieved one. The second achieved in differentiation, we got find the gradient of the curve defined by this equation at the point where x equals to 2. So we call this f of x equals 8 ln of 3x minus 2, which means f dash of x would then equal 8 over 3x minus 2 multiplied by the differentiation of whatever's inside the little bracket, which is 3 in this case. And so we have 24 over 3x minus 2 as our gradient function. So to find the gradient at x equals to 2, we're trying to find f dash of 2. That's 24 divided by 3 times 2 minus 2. So we have 24 over 6 minus 2, 24 over 4, and the gradient is equal to 6. Okay, so that's the differentiation one. And now on to the integration one. All right, so for this question, we've got a couple of information here in terms of integration. First one is that when f of x not f of x. When you have x equals 2, y equals 10, so we can write f of 2 equals 10, and the gradient is 8. So f dash of 2 equals 8. So from here, I have y double dash equals 6x squared minus 6x. So y dash is equal to 6x cubed over 3 minus 6x squared over 2 plus c. So this basically means I've got f dash of x equals 2x cubed minus 3x squared plus c. Now because f dash of 2 equals 8 from the top here, I can say that basically f dash of 2 equals 8. So I can put this as 8 is equal to 2 times 2 cubed minus 3 times 2 squared plus c. So this ends up being 8 equals 16 minus 3 times 4 is 12 plus c. So 8 is equal to 4 plus c, and c is equal to 4. So my f dash of x is now equal to 2x cubed minus 3x squared plus 4. So when I differentiate this, integrate it, I'm going to get f of x is equal to 2x to the power of 4 over 4 minus 3x cubed over 3 plus 4x, and of course plus another c. Now this can be simplified as f of x is equal to x to the power of 4 over 2 minus x cubed plus 4x plus c. And once again, we've got f of 2 equals 10. So I can write this as 10 equals 2 to the power of 4 over 2 minus 2 cubed plus 4 times 2 plus c. So 10 is equal to 8 minus 8 plus c. And this simplifies to 10 equals 8 plus c. So c is equal to 2. So my original equation that I was looking at would be y equals to x to the power of 4 over 2 minus x cubed plus 4x plus 2. And that's it for this session, guys. Thanks for watching.